When we are looking at an EKG rhythm strip, what exactly are we looking at? Let's examine each section of the EKG. Let's start with the EKG Graph paper. Panel 1 of the Pocket RCAT for Arrhythmias illustrates all the EKG rhythm waves and cardiac intervals with their relationships to the EKG Graph paper. This graphic illustrates the EKG paper that consists of horizontal and vertical lines that form a grid. The distance between each small box is 0.04 seconds, or the same as 1 millimeter. Time is measured horizontally, with each small square representing 0.04 seconds. Amplitude, the force of electrical impulse, is measured vertically with each small square equaling 1 millimeter. One large box measured horizontally is 5 small boxes times 0.04, equaling 0.20 seconds. One large box measured vertically is 5 small boxes times 1 millimeter, equaling 5 millimeters. The EKG badge is designed and calibrated to accurately measure all cardiac intervals. The calibrated red boxes on the EKG badge make it simple to accurately measure cardiac intervals without the need to tediously count little boxes. In this example, you see that 5 small boxes equals 1 large box. Let's understand the baseline. The baseline is also referred to as the isoelectric line. The baseline represents the absence of electrical activity. All cardiac waveforms and intervals begin and end at the baseline. Here we'll illustrate measuring electrical amplitude using the EKG badge. The EKG badge, with the clear window and the red baseline, lets you view the entire complex for ST changes or ST deviation. Now, let's examine the cardiac intervals of the EKG complex. To measure the cardiac intervals, we use the P, Q, R, S, and T waves. Depending on the leads, the Q wave may not always be visible, and the S wave may or may not extend below the baseline. Now let's take a look at what the waves and cardiac intervals represent, starting with the P wave. The P wave represents the electrical depolarization of both the right and left atrium, traveling down the internodal tracts to the AV node. Repolarization of the atria is usually not seen on the rhythm strip because it is buried in the QRS complex. Now we'll examine the PR, the QRS, the ST, and the QT segments. The first interval is the PR interval. The PR interval represents the time it takes the electrical impulse to be conducted through the atria and the beginning of the ventricular depolarization. Because the electrical impulse travels faster than the actual mechanical contractions of the heart muscle, the electrical impulse is delayed in the AV node to let the blood in the atria empty into the ventricles. You measure the PR interval from the beginning of the P wave to the beginning of the R wave to get the PR interval. Using the calibrated red boxes on the EKG badge, you can accurately measure the PR interval. Here you have a PR interval of 0.20 that is within the normal range of 0.12 to 0.20. Now, let's look at the QRS interval. The QRS complex usually contains 3 waves. The Q wave is the first negative deflection after the P wave. The R wave is the first positive deflection after the P wave, and the S wave is the first negative deflection after the R wave. From the AV node, the electrical impulse travels through the bundle of His, then travels through the bundle branches, then into the Purkinje fibers. The QRS represents ventricular depolarization. You measure the QRS interval from the beginning of the Q wave or the beginning of the R wave if the Q wave is not present to get the QRS interval. Using the calibrated red boxes on the EKG badge, you'll see the QRS interval is 0.10, which is in normal range. Next, we'll look at the ST segment. The ST segment is the segment from the end of the S wave to the beginning of the T wave. The J point is the junction between the end of the QRS complex and the beginning of the ST segment. Changes or deviation in the ST segment as little as 1 millimeter above or below the baseline may indicate cardiac problems. Every cardiac interval, including ST deviation above or below, is measured on the baseline. Using the EKG badge in this example, you can see that the rhythm shows normal sinus rhythm with no ST deviation. Here, you see inverted T wave, or T wave deviation. Compare this to normal sinus rhythm. In this example, you have ST depression or ST deviation below the baseline. Compare this to normal sinus rhythm. Here you have ST elevation or ST deviation above the baseline. Compare this to normal sinus rhythm. With all of its precision measurement capabilities, the EKG badge is the ideal tool for both EKG rhythm strips and 12-lead EKG interpretation. Now we'll examine the T wave and the QT interval. The T wave represents ventricular repolarization. The QT interval represents depolarization and repolarization of the ventricles. Measure the QT interval from the beginning of the Q wave to the end of the T wave to get the QT interval. Using the calibrated red boxes on the EKG badge, you can see you have a QT interval of 0.40. Panel 2 of the Pocket RCAT for Arrhythmia explains how we count boxes between the R to R interval to get the heart rate. With the calibrated red boxes of the EKG badge, the tedious practice of counting little dots in boxes with calipers, paper, and pencil is no longer necessary to achieve precision measurement. Even with a variable heart rate, you can see how easy it is using the badge to get accurate measurement. Now that you're familiar with the EKG waveforms and the cardiac intervals and how they correlate to the electrical impulses and the mechanical contractions of the heart muscle, let's take an in-depth look at the 39 individual EKG rhythm strips in the Pocket RCAT for Arrhythmias. The EKG badge comes with 2 badge slots so it can hang horizontally or vertically behind your name badge. EKG Concepts, developing precision educational tools to improve medical confidence.